In this lecture, we'll talk about the register calling conventions and what happens when I have a function that is invoked inside a loop. There are two very important concepts in this lecture. One is the idea of the calling conventions. The calling conventions exist to enable isolation between the implementation of two functions, the caller and the callee. What we want is for us to be able to replace one of the implementations. For example, I can rewrite the callee completely without having to inspect what the caller is doing, or vice versa. I should be able to rewrite the caller without inspecting what the callee is doing. And for that to be possible, there must be a contract between the caller and the callee about which registers each one of those functions is responsible for saving. For example, all the S registers must be saved by the callee if the callee changes their values, because the caller expects that the original values that were in those registers will still be there after the call. On the other hand, the A registers and the T registers are not preserved by the callee. Therefore, if the caller wants those values to after the call, the caller will gonna have to save the value before the call and restore the value after the return. The other important idea and concept in this lecture is the idea of data flow. We should always analyze all our programs, whether in assembly or any other language, considering the flow of the values into the program. For each use of a value, we need to find where is the definition, where does the value come from, and how does the value flows through the program. If we always use the principle of considering both control flow and data flow when analyzing our programs, we'll generate much better quality code. So let's start the lecture with an example. And this example has something wrong on it. So what this example, this is a very simple example. So there is some code that we are not showing that will put the value of a variable s into the register, into the register A1. Then there will be a call to a function bar, and this call to function bar will return the value of a variable t, so it's returned into a 0. Then what I want to do is to compute the value of t plus s, and I will return the function foo itself will return the value of t plus s. So the code appears okay, right? This a0 here is the value returned by the function bar, and I'm adding to a1, which was the value that contained the register that contained the variable s. So this should be computing the value of t plus s, and then this return will return in a0 the value that I want. However, the problem here is that after the call to bar, the value of a1 is unknown, because the calling convention establishes that bar may change the value of any of the A or any of the T registers. Therefore, bar could have used A1 for some of its computation, and when I return from bar, the value in A1 is no longer the value of the variable s. Now let's look at another example where we're going to have a function call inside a loop. This function foo now will initialize the variable of sum to 0, and I'm using the register t1 to store the value of sum. Then it will gonna test whether a0 is equal 0. a0 is the parameter for the function foo, so in this case the comment is telling me that I call that parameter n, and I'm asking whether n is equal 0. If n is equal 0, I'm done. Otherwise, I will subtract 1 from the value of n, and then I will call a function bar, and I'll be passing the parameter n to the function bar. And when function bar returns, I'll be adding the value of t that is returned to by bar to sum, which is t1. So I have this addition, and then I'll go to the next iteration of the loop that is over there. So I'll execute this loop, and every time this loop is going to be invoking the function bar to the current value of n, and I'll be going around the loop until the value of n is 0. What's the problem with this function? The first problem occurs, and by the way, when I'm done, I will make the a0 equal the sum, so I'm going to copy t1 into a0. So what's the problem with this function? The first problem is that the value of t1 after the function called to bar is unknown, because remember that bar can change the value of all the t registers without first saving their values and returning in the end. And I can identify this by noticing the flow of control in my program. This jump at the end of the loop goes back to the beginning of the loop. So what I have here is that I have defined the value of t1 at this line, and then I have gone around the loop, and I'm using the value here. But the problem is that between the definition and the use, there is a function call. And the function call will potentially change the value of the t register. But that's not the only problem in this code. I have another problem, and the other problem happens. So one thing that I can do to fix this problem, is to change the value of t1 for s1, because the contract with bar is that bar will not going to change any value of any s register without first saving and then restoring it. So now I can be sure that s1 contains the value of sum after the function to bar. However, there is a second problem in this code, and the second problem happens because of the value of a0. a0 will have been changed by the function bar. So I had the value of a0 initially in my program, and so that when I first start my program, the value of in a0 was my variable n. I subtract 1 from n, and then I call bar. When bar returns, the value that I have in a0 is whatever bar returned to me. It's no longer the value of n. So I have a second problem here, and how I solve this problem is by making a copy of a0 into s0 in the beginning, and then using s0 as my n variable. Now when bar returns a0, a0 contains the value returned by bar, that is my t value, and I can do the sum, update the sum, and I don't have any problem now with bar changing any of the registers that I want the value for. But as the slide indicates, there is still something missing in this code, because according to the calling conventions, foo itself cannot change the values of s0 and s1 without first saving and then restoring the values at the end. The other problem is that foo is making an invocation to bar. Therefore, foo must save the return address when it first starts, and then must restore the return address before it ends, because if I don't do that, this return here will return to this instruction, and I'll create an infinite loop. So how do I solve that? I solve that by, let's look at my final function foo now. So this is the foo that we saw in the previous slide. There is the loop. When I'm done, I'll copy the value of s1, that's my sum, into a0, and I'll return. So the code that's missing here is the code to save the registers RA, S0, and S1, And I'll need to subtract 12 from the SP because I need to save 3 registers, and each register occupies 4 bytes, so 3 times 4 is 12. So this is the code to save the values of RA, S0, and S1 so that I can make this code correct. And here's the code now to restore. I must restore from the same positions in memory where I have saved each of the registers. So this is the code to restore the values in the end so that the caller of foo will see the same values in S0 and S1 that were there before the call to foo happened. And this return address now is correct because it was saved in the beginning of foo and it was restored in the end of foo. So this value here is no longer the return address for bar. Bar on itself may have to save and restore registers too, depending on what bar does. But as I said before, we want the principle of isolation. We do not need to worry about what bar does, which registers bar uses, if we follow the convention. We also do not need to worry about the many different colors that foo may have. Remember that a function may be called from many different places. And we don't need to worry about any of those places as long as we follow the convention. We know that the overall program will work as for this version of foo, because this version of foo now follows the calling conventions. So the main idea in this lecture was to call attention to everybody that when I have a function call inside a loop, there is flow of values that goes from the end of the loop to the beginning of go around the what we call the back edge, because I go back to a place that I have been before. And this flow of value, if it goes through a function call, I need to be very careful about which registers contain values that I care about. In this case, there were 2 registers that bar would have changed, and that my original code was expecting those values to be unchanged.